This time, let's learn how to solve your quadratic equations in one unknown. So a second degree equation of one variable, which is in the form ax squared plus bx plus c equivalent to 0, where we know that a, b, c's are constants or they are real numbers, may be solved using the following methods. So you have three options to solve. Your quadratic equation can be solved by factoring, it can be solved by completing the square, or we can solve it by quadratic formula. To start off, let's solve your quadratic equations by factoring. As you know, and as we have learned previous to this series of videos, we have already discussed how to manipulate algebraic functions. We have learned everything about polynomials, how we solve, simplify, how we factor them, what are the special products that we have for them. Okay, and all of those skills, your manipulation skills in algebra, are very useful when solving for quadratic equations, when solving for the unknowns of your quadratic equations. Okay, so the first thing to do is, when you're solving by factoring, you have to represent or you have to present your equation in its standard form. Ibig sabihin, kailangan po ang equation natin ay naka ax squared plus bx plus c equivalent to 0. Or sabihin natin, dapat ang equation mo naka-equate siya sa 0. Which means, dapat po lahat ng terms on the right side of your equation be transposed to the left side. Okay? So what we're going to do with number 1 is, I'll get my notes first. It's easier to do it in our notes instead of in the PowerPoint. Okay, so let's write here quadratic equations. And our first solution to quadratic equation is to solve them by factoring. Okay, again, the note is that if you're given a problem or a polynomial or a quadratic equation, it must be transformed to its general form. That means it should be equated to 0, or the right side of the equation must be equated to 0, which means everything on the right must be transposed sa left, okay, so that you get 0 on the right side. Therefore, this particular equation that you have for number 1, you have x squared plus 2x. So I arranged it in such a manner that you have a first, or your second degree term first, followed by your first degree term to be followed by your constant equated to 0. So I wrote 2x first, where if you transpose 2x, it will become positive on the left side, minus 3 equivalent to 0. And then we're going to think of the factors of this equation, where we have x and x for the first term. If you take that product, it will produce x squared. We are going to think of factors of negative 3, whose sum will give us positive 2. Okay, so for negative 3, you have maybe two options. You have negative 3 times positive 1, or you have positive 3 times negative 1. In these two sets, which of these will show us a positive 2 sum? Of course, that is your negative 3 plus negative 1, right? Negative 3 plus negative 1, that gives you positive 2, which means we'll be using this as factors in this equation, okay, or in this factored form. So we have x plus 3 and x minus 1. And of course, we equate this to 0. Okay, equating this to 0. The next thing you're going to do is to write each of the factor and equate it to the right side of your equation. So get one of the factors, let's say x plus 3, and then equate it to the right side of your equation, which is 0. And do the same for the next factor. So we have x minus 1, and then equate it also to the right side of your equation. And that shows that you have, if you transpose this to the right, you'll get x equivalent to negative 3. And then for the other factor, you get x equivalent to positive 1. And these two gives you the two roots that you have for your quadratic equation. So previously, maybe when you learned this in high school, you were told to write this as x sub 1 equal to negative 3 and x sub 2 equal to positive 1 to show the first and the second roots that you have for a quadratic equation. One thing you have to remember for quadratic equations, or for quadratic equations and similar to other equations that you might encounter, the highest degree gives you the numbers of roots that you have for that particular equation. So if this is quadratic and your highest degree is 2, that means you should be able to come up with 2 roots, okay, for your quadratic equation. Okay, let's try to solve letter B. In letter B, we are given x minus 4 equal to 21 over x. If there's a problem in this equation, that is, it has fraction. Okay, and most specifically, the denominator is your unknown, which is x. So our goal here is to remove the fraction by simply multiplying both sides by x. Because if you multiply the right side by x, that cancels x in the right side, thus removing the fraction. But since we have to maintain balance in the equation, what you do on the right, you do on the left also. So I multiply the left side by x also. What would happen? You will get x times x minus 4 on the left side of your equation. Okay, but on the right side, you'll only get 21. Okay, and in this way, if you wanted your quadratic equation, what you do is you expand the left side. So that's by distribution, you get x squared minus 4x, okay, equivalent to 21. If it asks for the quadratic equation, that would be x squared minus 4x. You transpose this to the left, so that's minus 21. Equate it to 0. This gives you the general form, okay? A common mistake, just to share, a common mistake that students do when they solve for quadratic equations by factoring is they tend to forget that the equation needs to be transformed to its general form first. Because after multiplying both sides by x, they get to seem, or they think they're allowed now to solve for the roots because the left side is already in the factored form, which is incorrect. Why? Because the right side is not yet equated to 0. You have a term in the right side which is a constant, and by rules of solving for the roots, it should be in the general form. Okay, so it's only proper that after multiplying both sides by x, you transform it to the general form before we proceed with factoring. Therefore, we go back to your general form and we factor. So this general form, which is x squared minus 4x minus 21 equivalent to 0, would be factored into binomials of x and x for x squared. Okay, we have to think of factors of negative 21 that if you sum them will give you negative 4. So we have negative 7. You have two options. You have negative 7 and positive 3, or positive 7 and negative 3. And between these two, this one would give you a sum of negative 4. So that's negative 7 plus 3, that gives you negative 4, which means we write this, okay, as part of the binomial. So we have x minus 7 and x plus 3. And then, of course, equate it to 0. After being able to completely factor the left side of the equation, you get each of the factor, that's x minus 7, and you have x plus 3, and you both equate it to the right side of your equation, which is 0. From there, we solve for x of each of the equation by transposing the constants to the right. You get x equal to 7, and in here, you get x equal to negative 3, which gives you your x sub 1, the first root, and your x sub 2, which is your second root. For me, it doesn't matter if you write it as x sub 1 or simply just x sub 2 or simply just x. But we know for sure that these are your answers. These are the roots of your quadratic equation. Okay, let's proceed to our last example, which is letter C. And in letter C, we are given x plus 12 is equivalent to 12 all over x plus 1. Similar to the previous example, the only difference is that you have a binomial in the denominator. Still, the target is to be able to remove that fraction by multiplying both sides by that denominator, and that is x plus 1. In that sense, you'll be able to cancel it on the right side, but we were able to manipulate the problem, so we multiplied the left side also by x plus 1 so that we get to balance the equation. So what would happen is that you have x plus 1 to be multiplied to x plus 12 on your left side, and then on your right side you have 12. Since the right side is not yet 0, you have to expand your left side, okay, transpose the constant to the left, to equate it to 0 so that we are in general form before we go back to factoring. Okay, so expanding this, we use FOIL method. Of course, you have your first terms, so that's x squared. Okay, your outer terms, so that's x times 12, so plus 12x. The innermost terms, so you have 1 times x, so that's positive x. And your last terms, which are your constants, that's 1 times 12. So you get positive 12. Equated to 12, okay? And then we simplify this by transposing everything on the right to the left. So you have, and of course, simplifying whatever you already have on the left. So you have x squared. These two terms may be simplified because they are similar. So you have 13x plus 12 minus 12. If you transpose this, equate to 0. And that gives you this to be cancelled, which means you're left with x squared plus 13x equivalent to 0. To factor, you have a binomial on the left side where x is common. So what I'm going to do is factor that common term, that's x, and you'll have x plus 13 to remain in the binomial. Equate that to 0. As you can see, your left side is now completely factored. You still have two terms, or you still have product of two terms on the left side. You have this one, which is x, to be multiplied to x plus 13, which is almost similar to the previous ones. The only difference is that here you have binomial multiplied to binomial. In this example, you have a monomial multiplied to your binomial. Either way, you write each of the factor, right? Okay, and equate them to the right side of your equation, which is 0. On the left side, on your first factor, that already shows you that x is equivalent to 0. This is our first root, or you can write it as x sub 1 is 0. Okay, and on the right side, of course, we transpose the constant to the right. You'll get there x equal to negative 13, and this gives you your second root. Which means this equation, x plus 12 equal to 12 all over x plus 1, has the roots 0 and negative 13. Okay? If you wanted to check if your answers are correct, there is one basic method in checking, that is by substitution. So what you do is, if you are given, let's say for example, example number 1, you have x squared equal to 3 minus 2x. To check, you can use one of your roots. So let's say, let x be equivalent to negative 3. I'm using my first root here. What you do is simply substitute it to the equation. So that would be negative 3 squared. Is it equal? Will it be equivalent to the right side, which is 3 minus 2? That's times negative 3. Okay, so you have positive 9 on the left. Will it be equivalent to the right? So that would be 3 plus 6. That's 9. So check. Okay, that's one step. You can check your answers if they're correct. If they are roots or solution, they should satisfy the equation. That means if you substitute them to your equation, it should justify that the equation is correct. Okay, another way of checking your answers if your roots are correct, and since we are able to use them, is through your calculator. So what you do is get your calculators. Okay, in your calculators, so let me just get my equation. And I'll overlay the calculator here. Yeah, okay. So get your calculator. In your calculator, if you're using a Casio, you have an option, you have options there. So dito kasi when I press mode, I already have the options I can use. But if you're using your Casio calculator, you have to press mode. Okay, you have to press mode. And then you have to look for option 5. So I'll just write here, in your calcu, press mode. Okay, among the options there is 5.eqn. So choose 5. After choosing 5eqn, it will give you the following options, like this one. Okay, so your options will be, you have, after pressing 5eqn, you will have 4 options. You have 1, 2, 3, and 4. For quadratic equations, we choose number 3. Okay, number 3 shows there that you have ax squared plus bx plus c, which is equivalent to 0, and which hindi kayo maliligaw because this is your general form. of your quadratic equation. So you press 3. Okay, press 3. After pressing 3, it will show you a table which has ABC, and then you have a row there that contains 0, 0, 0. So this is where you will input your values. Okay, so if you already have your quadratic equation, let's take the first one. So make sure that before you do this, before you check it in your calculator, it should be in this form. So I'm going to take this one. I'm going to take this one. That's x squared plus 2x minus 3 equal to 0. That's x squared plus 2x minus 3 equal to 0. What you're going to do is just get a, b, and c, including the sign. So for x squared, I do not have other constants than positive 1. So you press 1 for the area or the cell under A. So let me erase this. Okay, so you're going to press here 1 and then press equals. Okay, and then for the b term or for the b constant, that would be 2. That's for your linear term. So you're going to press 2 here. Okay, after that you press equals again. And then for the constant we press negative 3 for the last cell because this is negative in sign. Okay, after pressing negative 3, you press equals. Okay, after pressing equals, press another equal sign. Okay, another equal sign, and it will show you an x sub 1. And if you press another equals to that, it will give you an x sub 2. So its x sub 1 is positive 1, its x sub 2 is negative 3. And these are the roots of that quadratic equation. Going back to our solution, our answer is negative 3 and positive 1, which is similar, right? The only difference is that the sequence of answers. So this one was our second root. This one was our first root. Pero in your calculator, it will appear as 1 and negative 3. If you downloaded the same calculator I'm using in this presentation, then you just look for your polynomial in the second degree. This is this one. Solve polynomial in second degree. And then you just do the same process. Okay? We input the numerical coefficients that we have in our term. So your second degree term has a numerical coefficient of 1. Your first degree term has a numerical coefficient of 2, and your constant is negative 3. You press equals. Okay, press another equal so that it shows you your constants. And in this calculator, it gives you negative 3 as the first root, and then you have positive 1 as the second root. So you just press equals so that your answers show up. Okay, that's how you check it with your CalQ. You are allowed to use your calculator since you are engineering students and you're now in college. And this is how we solve by factoring.